Hello everyone. Welcome to the presentation of the Apex Tournament of Zacatecas 2. Our project is Ring Terminal Waste Elimination. We are the Scrap Hunters. The team is made up of Marlon Bermudez, Final Assembly Group Leader of the Manufacturing Area. Ursalia Acosta, Lead Prep Group Leader in the Manufacturing Area. Adriana Ramirez, Manufacturing Engineering Technician, and Omar Celaya, Manufacturing Engineering Technician. Our plant is located in the city of Zacatecas, Mexico. Started operations on August 12, 2013. We currently have 34 production lines that operate in 2 shifts, 3,900 employees, and more than 9 million harnesses are produced per year. Our harnesses are distributed in Mexico and the United States to our clients Daimler, located in the state of Aguascalientes, Mexico, FCA Sterling Heights and FCA Windsor located in the United States. Our project was born from the review of the plant indicators at the beginning of this year. During the last semester of 2020, a clear trend is noted in the increase of scrap. The objective is not to exceed 0.34% of the sales volume, however the result was 0.48%. According to the data collected, full process is the area that generates the most scrap. However, this is normal due to the nature of its process, and, as can be seen in the graph, it is within target. The information analysis indicates that Ensemble Final is the biggest detractor by presenting a gap of $15,000 with respect to its annual objective. So this is where we focus the development of the project. To understand the problem that causes high waste in final assembly, we begin by identifying the areas with the greatest problem. Final assembly is divided into 3 platforms: DT, RU, and MFA. In this case, DT's platform is the largest contributor to scrap in final assembly. Analyzing the DT platform, we find that the DT001 IP line is the one that generates the most scrap. This line produces harnesses for the instrument panel of the Dodgerum truck. The scrap generated in line DT001, according to the data collected, is generated mainly by 4 causes: damaged plastic component, cable without terminal damaged, cable with damaged terminal, damaged ring terminals. The latter is the one that has the greatest impact on cost. As a first step, measures are put in place to contain the problem and prevent it from increasing the volume of scrap. Line and lead prep group managers review the ring terminal assembly process to ensure that it does not contain defects and is not damaged in transit to the production line and assembly to the construction board. Additionally, the area supports validate that the construction board tools are in good condition and are not the cause of damage to the terminals. A complete review of the construction process is done to determine in which step the problem is generated. All problem harnesses are inspected to identify any defects they contain. All defects and assembly problems are documented in the first-time quality system. The results indicate that the assembly process of the terminal in the area of let prep and transfer to the construction line is correct. However, the problem starts at the station 12, which assembles the terminal in construction board and causes the rest of the process to be affected. All team members met to brainstorm and develop an Ishikawa diagram to identify possible causes of the problem. During the analysis, construction problems, tools in poor condition, poor terminal construction, problems with labor and execution of work methods were considered, and we were able to identify 2 possible causes. 1. The terminals are poorly stored, and 2. Reprocessing and repair of harnesses is mainly due to excess and/or missing tips from the terminal. After evaluating the possible causes found in the previous step, it was determined that the problem is generated by the lack of space in the rack for the ring terminals. In recent months the customer requirement has increased. This causes an increase in the volume of parts and part numbers to be produced. For this reason, the shelving for the ring terminals is insufficient for the operators that supply the material to achieve the correct arrangement and identification of part numbers. Line operators, not having the correct location of the part numbers of the terminals, place the wrong terminal in a construction board. To solve the problem, a new rack was designed with enough space to properly organize all the different part numbers of the ring terminals. To determine the size of the new rack, the customer requirement volumes per day, the number of different part numbers produced, and the different ring terminal options that apply to each part number were reviewed. With this information, it was established that the new rack should have two levels and 14 positions to store all the part numbers of ring terminals that are currently used. Each position in the rack is identified with a label that allows to keep all the bundles of the ring terminals organized. The height of each tier and the spacing between bundles was designed so that the tips of the terminals are not damaged when placed in the rack and that the line operator has easy access. The identification labels contain the part number of the ring terminal and the option or variant with which it is built. With these data, the final assembly operator can correctly identify the terminal that must be mounted on the panel according to the part number that is being built at that moment.